Good morning, class. We're looking at practice test number 4, module 4, chapter 7 and 8. Chapter 7, systems of linear and nonlinear equations. Chapter 8, analytic geometry. Here's the pledge I expect everybody to read when they take the exam. In short, I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. The idea is that no notes, no PowerPoints, nothing. You may use a scientific calculator. In some cases, maybe a graphing calculator. So here's chapter 7, systems of linear and nonlinear equations. Number 1, if the system of linear equations results in two parallel lines, the system is inconsistent. What is an inconsistent system? The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. So if you solve for y, you see that m1 equals m2, but b1 is not equal to b2. If you go with addition method, for example, or substitution, you end up with a contradiction, such as 0 equals 7, which indicates there is no solution. If the system of linear equations results in two intersecting lines, the system is consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So M1 is not equal to M2. That's the bottom. And finally, if the system of linear equations results in a single line, the system is consistent system with dependent equations. Many times we just call them dependent. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. They coincide. They are at top of each other. In other words, if you solve for y, they become identical. M1 equals M2, B1 equals B2. And if you were to solve it by addition method or substitution, you get an identity, for example, 0 equals 0, 5 equals 5, and so forth, which indicates the system has an infinite number of solutions. The equations are dependent. So this is the synopsis of systems. Of course, of two equations, two unknowns. We want to solve the system minus x plus 2y equals -1, 5x minus 10y equals 6. You may use any methodology. You may notice addition method will do the job. The idea of addition method, also known as elimination, is that you eliminate one of the variables. For example, you notice if you multiply this one by 5, you get minus 5x with 5x. They cancel each other. So let's multiply by 5, the first one, meaning the second one remains unchanged. The first one, now we get minus 5x plus 10y was -5. It so happened that everything cancels out on the left side, and you get 0 on the left side. The right side, they add up to 1. 0 equals 1 is a false statement. Therefore, this is an inconsistent system. The solution to this system is an empty set. So these are the notations for empty set. This is phi. This is a couple of braces with nothing in it. Now, if you were to solve for y, in each case, you end up with lines having the same slope, different y-intercepts. What about this one? If I want to solve, if I want to go by the elimination or addition method, if I want to get rid of the x, I can multiply this one by 5, this one by 2. If I want to get rid of the y, I can multiply this one by 3, this one by 7. Again, depends on what we want to do. So let's multiply the first one by 3 because we want to get rid of the y. We get 6x minus 21y equals 9 for the first one. The second one we multiply by 7. Remember, when both sides are multiplied by any number other than 0, you keep the same type of equation. So minus 35x plus 21y equals 49. So now the coefficients of y are opposites. So if we add them up, these two cancel each other. These two add up to negative 29x. These two add up to positive 58. X is negative 2. Now you put that back into one of the original equations. For example, if you go with the first one, 2 times x, that means 2 times minus 2 minus 7y equals 3. So we have negative 4, and we make it positive on the other side. And it becomes 7 divided by negative 7. Y becomes negative 1. And I like to write it as a pair, negative 2 comma negative 1. Now it is extremely important to check. How do you check? Well, we used equation 1. All we have to do, check with equation 2. Minus 5 times x, negative 2, plus 3 times y, negative 1, is this equal to 7? It checks. It literally takes you seconds and no more to check your work. I highly recommend you do that, everybody. Always do that. Matrices. A rectangular array or table of numbers. That's the basic definition. A matrix with m rows and n columns has dimension m by n. So we have, as an example, 1, 2, 3. This is m rows, 1, 2, 3, and so forth. That's n columns. M by n. That's I, and that's j, by the way, the ith row and jth column. A square matrix has the same number of rows as columns. The dimension of a square matrix is n by n. We can add matrices with the same dimensions only. So if we have the same dimensions, all we have to do just add up the same location. For example, this one will add up with this one. The general location is A, I, J. I represents the row, J represents the column. So see A11. So when we add these two, we get 1. We can add these two, same location, we get 0. We can add these two, we get 16. We can add these two, we get 6. That's how addition is very simple. Same location, add them up, you're done. Product is a different story. The product AB of an m by n matrix A and n by k matrix B is an m by k matrix. In other words, if you're multiplying two matrices, the first one, the number of columns, the second one, the number of rows must be identical or you can't. So notice this one has 2 rows. So let me just write the dimension. So the very first thing you do is write the dimension. This is 2 by 3, everybody. 2 rows, 3 columns. This one is 3 by 2. Now, I want to emphasize, since this is 2 by 3, this must be 3 by any number will do the job. Okay. It's just happened to be 2. And the resulting matrix, I highly recommend when you want to multiply, write the size. So this is 2 by 3, this is 3 by 2. When you want the result, the number of rows comes from the first one and the columns comes from the last one. 2 by 2, the result is 2 by 2, everybody. So you choose this one, choose this one, and the result is 2 by 2. And the way we multiply and add is as follows. This row gets multiplied by this column, add them up, and that would be the first entry. So to get an idea, -3 times -6. So this is what we add, what we multiply. -3 times -6. I'm going to write it up there. So let me use a different color. -3 times -6 plus 4 times 2 plus 2 times 3. We have 18 plus 8 plus 6, and the answer is 32. So the very first entry, this one is 32, everybody. Then we multiply these two, and let's just write it here. Negative 3 times 4. 4 times 3. 2 times negative 2. So this is negative 12 plus 12 minus 4 times is minus 4. So this is minus 4. And then you multiply this one by this one, you put it here. Multiply this one by this one, you put it here. And I leave it for you to figure those out. I did this two for you. I highly recommend you try to multiply this one by the first one, you get this one. And by this one, you get this. All right, so that's how multiplication works. Matrix methods to solve systems of linear equations. REF stands for row echelon form method. Apply row transformation to get ones along the diagonal. This is called the diagonal main diagonal. A leading coefficient is 1, in other words. And 0 is below. So this is 1, everything underneath is 0. 1 underneath 0. 1 underneath 0, all the way to the end. Above doesn't have to be. The augmented, this happens to the augmented matrix, okay? Now, REF is called reduced row echelon form, which means apply transformations to get ones along the diagonal and zeros both below and above the augmented matrix. So 1, everything 0, 1, everything 0 underneath and above. 1, everything 0 below and above. That's the difference. In which case, the last column is the solution. So every leading one is to the right of the one above it. And any non-zero rows are always above rows with all zeros. So that's the definition of a row echelon form and reduced row echelon. And of course, all the zeros go at the bottom. Solve the system. Minus x plus 2y equals minus 1, 5x minus 10y equals 6. And we know how to do it by substitution method, by addition method. Now, let's do it by the method of matrices, everybody. First, we are going to come up with the augmented matrix. So what is the augmented matrix again? You just write everything here, just the coefficients. So you have a matrix, minus 1, then 2, then negative 1, the second one, 5, negative 10, 6. Or if you want to go column, negative 1, 5, 2, negative 10, minus 1, 6. So this is called the augmented matrix. Normally, here's what we have, each piece. This is called the coefficient matrix. So that means simply the coefficient of x and y. The last column represents the constant, the answers on the right. Each column on the left represents a different variable. So this is the x variable, this is the y, and if we have more, z, and so on and so forth. This acts as an equal sign, this line segment. So now the methodology is to make the first entry 1. There are different ways of doing it. Right now, the easiest way, if I multiply the entire row, and remember, when you multiply the row by a number, that means you're multiplying the equation by that number. And that is one of those transformations which is acceptable. So row transformation, what can we do here? Let's multiply this one by -1. So you write minus row 1 goes to row 1. So this means, simply put, you keep the second one intact, you multiply the first one by negative, this becomes positive, negative, positive. Again, look at this one and look at the change. Now, the next thing is, as soon as you get the 1, everything underneath, there's only one item, but let's say there were 10 of them. Each and every one of them, you want to change them to 0. How do we do that? Well, if I multiply this one by 5 and subtract it from this row, this becomes 0. Remember, you can add multiples of an equation to another one, right? So that's another one. So I'm going to multiply this one by 5 and subtract it from this one. So I'm going to write minus 5 R1 plus R2 will be the new R2, which means the first row, row that we have is not going to change. So this one, if I multiply by 5, becomes 5. Subtracted from 5 becomes 0. This one I multiplied by 5, -10. Subtracted from -10 becomes 0. Okay. This one I multiply by 5 becomes 5. Subtracted from 6, I get 1. So those are very straightforward, everybody. The corresponding equation for the last row, 0 equals 1. If you look at this row, what does it mean? Remember, that's the augmented matrix. What if we want to go back from augmented? We should be able to go back and forth. This last row means 0x plus 0y equals 1. This first row, by the way, means 1x, and I put 1 on purpose, minus 2y equals 1. Just to let you know what it means. Going back and forth from this system to augmented matrix to system. So this means 0 equals 1, which is a false statement. Therefore, the system is inconsistent, and the solution to the system is an empty set, Okay. So it's important to understand that. Now, if you go with graphing calculators such as TI, first you use the matrix editor to put the matrix in. So matrix editor found by pressing second x to the power of -1. Use the arrow key to the right to edit the dimension you want and press enter. Put all the entries using the arrow keys, press enter. So how to solve a system by a matrix, row echelon form, matrix editor. Again, you find in the same manner. Then you click on math. Then REF matrix A, node passing second x to the power 1, enter, bring up matrix A and enter. So notice matrix A, you make it the dimension that you want, 2 by 3, and you put the entry. Then if you go to math and say REF matrix A gives you this one. Now, it's important to know, based on the methodology that was used, the first row in this case may or may not look exactly the same. The bottom indicates exactly what we have here. So here's the calculator. Graphing calculator. You may be able to read the matrix here in blue. Second matrix. We go to edit and we make it 2, 5, 3. And now we enter -1, 2, -1, 5, -10, 6. So we enter the matrix. This is matrix A. We go back here. We go to math. We bring it down. REF. Second is -1. Matrix A. Enter. One more time. Second is -1. Math. We're going to bring it down to REF. And second, x -1, matrix A. Close parentheses. And it gives us exactly what you see here. 1 - 2, 1.2001. I just wanted to show you that how to enter a matrix dimension, a matrix itself, and then how to use the math part. Okay? So we're done with this page and we are going to move on. All right. We want to solve the system. So we are going to start with the augmented matrix, which means 2 - 5 - 7, 3, 3, 7. We want to make the first entry 1, so we can divide by 2. Here's the, and there's nothing wrong with that. We get 1 minus 7 halves, 3 halves. The problem is when you have fractions, makes it very difficult to work with. So again, I can divide everything by 2. That's the fastest way to get 1, but you have to deal with fractions. Instead, you notice this is minus 5. So if I multiply this one by 3 and add this one to it, this becomes 1. So 3R1 plus R2 becomes a real new R1. What do we mean by that? So if I multiply this one by 3, I get 6 and minus 5 is 1. If I multiply this one by 3, 3 times negative 7 is negative 21. Add this one, you get negative 18. If I multiply this one by 3, I get 9. Add 7, you get 16. And the second row remains unchanged. Okay. So we don't want to change this. So we rewrite this, but this we want to change it to 0. To change this to 0, if I multiply this by 5 and add to this one, so 5R1 plus R2. So if I multiply this one by 5, get 5 and negative 5, 0. If I multiply this by 5, I get negative 90. With 3 is negative 87. Negative 87. If I multiply this one by 5, I get 80 plus 7 is positive 87. Okay. Obviously, I want to change this to 1, divide by negative 87, or multiply by negative 1 over 87. So you keep the first row intact. This one, 0 divided by 87 or minus 87 makes no difference. This becomes positive 1, this becomes negative 1. And in essence, this is the answer. This there has two variables, x and y. So this is the second variable, y is minus 1. That's the meaning of it. So let's rewrite from the augmented matrix. Let's go to the equation. This means x minus 18y is 16. This means 0x plus 1y equals negative 1, which obviously means y equals negative 1. So if I go back to the first one, x minus 18 times negative 1 equals 16. We have x plus 18 equals 16. Subtracted, and you get negative 2. Okay, negative 2. Now, let's look at matrices. So I showed you how to enter the matrix 2 by 3. 2 by 3 we are talking about here, and you put 2 minus 7, 3 minus 5, 3, 7. If you do REF, it gives you this answer, everybody. So x is minus 1, and again, you have to solve just the way I did it. Over here, you would put x minus 0.6y equals negative 1.4. So this is not identical to this one. It doesn't have to be. However, if I put REF, this last column is the answer, everybody. Here's the reason. This means 0x plus 1y equals negative 1. This means 1x plus 0y equals negative 2. So REF will give you the answer. The last column is the answer, and we are done. So this is using matrices. We need to understand the concept. Use Cramer's rule to solve the system. So we are looking at the same system, but a different methodology. What is Cramer's rule? determinant. The determinant of a 2 by 2 matrix, which is ABCD, is denoted by their you can think of it as cross product, AD minus BC. By definition, determinant of a matrix is a number, AD minus BC. Now, Cramer's rule for two equations for a system of 2 by 2, where we have ax plus by equals s, cx plus dy equals t, and then x is d sub x over d, y is d sub y over d. So I want to explain what each one is. So I want to start with the D matrix is the coefficient matrix. A, B, C, D. I want you to pay just attention to D for now. D, the denominator, is the D matrix. Now for X, the X column, A and C changes to the solution column, ST. For Y, the Y column, the second column, changes to ST. So pay attention to the way it works. It's very straightforward, everybody. Now note. So D, the denominator, is the determinant of the coefficient matrix ABCD, and it's AD minus BC. If it can't be zero, it can't be zero because you're dividing by. Note, we replace the first column of D by the solution matrix D sub X, and we replace the second column of D by the solution matrix D sub Y. That's how we get the numerator. If D is zero, and at least one of the determinants, D sub X or D sub Y, or D sub Z, in this case, class D sub Z refers if you have a 3 by 3. If any of them is different from zero, then the system is inconsistent and the solution set is an empty set. There is no solution. If D is zero and all of those determinants are equal to zero, then the system is consistent and dependent so that there are infinitely many solutions. I want to recap the whole thing. So here's the system. Ignore the solution. This one gives you the bottom or D, and the determinant is AD minus BC. For X, drop the column that has X and change it to ST. For Y, drop the second column and change it to ST. That's how you find it. If D is zero, if the denominator is zero, but D sub X or D sub Y or D sub Z, if it happened to be a 3 by 3, if any of them is non-zero, then there's no solution. But if D is zero, and D sub X, D sub Y, D sub Z, whatever, however many, you may have a 4 by 4. All of them zero, then it's a dependent system, infinitely many solutions. So let's start with this. We are going to put 2 minus 7 minus 5, 3. That is the D. We do the cross product, 2 times 3 minus negative times negative 7. Six minus 35 is negative 29. Now D sub X, remember, you just change the X column with the result 3, 7, or the solution is, if you will. The solution. And now the cross product. 3 times 3 minus 7 times negative 7. Nine, negative times negative is positive 58. Now for D sub Y, We go back to this one, we keep this one, and we change this one to 3 and 7. Cross product, 2 times 7 minus 3 times -5. So we have 14 and 15. They add up to 29. X is d sub x over d. So 58 divided by -29, which makes it -2. Y is d sub y divided by t, 29 over -29, which is -1. And that's exactly what we found in the previous page. I hope everybody remembers that. So we had this previously. So as expected, the same answer. All right. What happens when it's a 3 by 3? You decide to expand it across some row, and that's your choice. You can go with respect with this row, this row, this row, or this column. You choose to expand it choosing any row or column. And the best course of action, choose the one which has the maximum number of zeros. And so with that being the case, if we want to go with this one, okay, let me see this row. Then you multiply this one. So you always cross this row, and if you want this one, you cross this one, you have this much. So look at this one. If for this one, everybody, you cross this one and you get this. A sub 1, 1 times whatever is left. Then you switch sign. It alternates. This is positive, negative, positive, and there's a different way I explain that one to you also. For the second one, you cross this one and you so you're looking at A12 with a negative in front, and look at this one. And the last one, A13 times, should do it. Okay. Now, the sign in front is -1 to the power of I plus j. And this is A11, 1 and 1 is 2, -1 to the power of that is +1. But this one, 1 and 2 is 3, odd makes it negative, and so on. But one way is to alternate. If they just understand the first one starts with positive, but if you start here, it starts with negative. So when I evaluate this, okay, so the 2 by 2 determinants are called minors of the 3 by 3 determinant. So the terminology, minors, depending upon the row, of course, that you decide. For this row, then the minors are those 3 determinants. So let's say we choose to expand across row 1. So what do we get? So 5 times what? Let me just cross this out so you can see that. This one goes away. So 5 times this. 0, 4, negative 2, 1. Second one, you always get rid of this. Whatever is left, 3, 4, minus 5, 1. And the last one, you get rid of this. So the first one would be positive 5 times what I showed you, minus negative 8 times what I showed you, and plus 6 times this. Okay. And in each case, we have a cross product. Let me, in this case, is 0 times 1, which is 0, minus negative 8. In this case, 1 times 3 is 3, minus 4 times negative 5, minus 1. In this case, 3 times negative 2 minus 6, minus 0, and the numbers in front remain 5, negative 8, and 6. So 5 times that, minus 8 times that, and so on and so forth. So this is obviously positive. So 5 times 8, this is minus 8, positive. 8 times 23, and 6 times negative 6. And we get 40 plus 184 minus 36 equals 188. So I hope everybody is okay with that. We continue with the determinant of a 3 by 3 matrix. We want to evaluate this one. There is a second method. So you put 2 of them next to each other. So you put this one, and then the same thing next to it. And you start from the very first entry, you go diagonally. Multiply them and add them up. And then from the bottom, the second one, go diagonally. Or you can say the last one, go diagonally down. You multiply, you add them up. So the blue ones add up, the red ones add up, the red ones subtracted from the blue ones. Okay. So this is the second method. So if I want to go with that method, I'm going to write this matrix and an identical matrix next to it. Again, I want to get to the same 188. I want to show you the second method. So I start from the first one and I go diagonally. And the second one and the third one. And that gives me 5 times 0 times 1 plus minus 8 times 4 times negative 5 plus 6 times 3 times negative 2. Now, the last one diagonally here and here and here. Now, when we do that, minus 5 times 0 times 6, minus 2 times 4 times 5, 1 times 3 times minus 8, and you add them up. The blue one, they add up to 124, minus the red ones add up to negative 64, they give us 188. So this is the second method, everybody. By the way, as far as if you did the last one, works out absolutely the same. You get the same result, everybody. So you can start with the first one. at the top and then first one at the bottom, just as I did here. Or first one at the top, you have to go with the first one and then you go at it with the last. So we get to the same answer. I think it's a tad easier. And note it is easier, expand across any row with most number of zeros, and that's extremely important. The one with has more zeros, that is wise to do so. For example, here you want to go with the second column or second row, and you can try it on your own. So it is easier to expand that way. Now, if I want to go with technology, and when it gets involved, you can use technology. We put a 3 by 3. That is the dimensions. We put the information and then determinant of matrix B, 188. And that's fine. For a 2 by 2, you should have no problem to do it by hand. For a 3 by 3, you may use a calculator. All right, I want to solve this system, and I want to do that a couple of different ways. Number one, by hand. So simply put, you are going to throw in equation 1, 2, 3, so we can go back and forth to it. And the idea is to eliminate the easiest variable that we can. Since this is negative 4y and this is positive 4y, it's easiest to get rid of the y's. And if I put equation 1 plus equation 2, I don't have to do anything. I just add them up. Just add these two, everybody. Equation 1 and equation 2. I get 5x here. These two cancel each other. I get 3z here. These two add up to 1. So that's equations 1 and 2. And we call it equation number 4. Now, if we get rid of the y in these two cases, that means I can multiply this one by 3. See, because this is negative 4, I multiply this one by 4. So let me erase my work first. So if I multiply this one by 3 and this one by 4, what happens? This gives me 9x minus 12y plus 6z minus 45. This gives me 8x, 12y, 20z, 80. And now, so I'm looking at equation 1 times 3, equation 3 times 4, and these two cancel each other. 17x, 26z, 35. And we call it equation 5. Now, what's happening, equations 4 and 5, they have x and z only. So let's put them next to each other. And now, this is the system of a 2 by 2. So let's go back. Originally, we had 3 equations, 3 unknowns. Now we have 2 equations, 2 unknowns. Okay. So we can get rid of one of the variables. For example, if you want to get rid of the x, you can multiply this one by 17 and this one by 5, one of them negative. So let's say the top one by 17, we get 85x plus 51z equals 17. And let's say this one by 5, negative 5, we get negative 85x, negative 130z, and negative 175. So clearly, these two cancel each other. Negative 79z, negative 158, divide, and z becomes 2. All you have to do, go back to one of the equations and find x here. Which one? Either equation 4 or equation 5. So if you go to equation 4, 5 times x plus 3 times 2 equals 1, we get 6 here. Okay. And subtract it from 1. 5x is minus 5, x is negative 1. We go back to one of the original equations. Let's say equation 1. 3 times negative 1 minus 4 times y plus 2 times 2 equals negative 15. So we have minus 4y plus 1 equals negative 15. You move this one, make this one negative 16 divided by negative 4. You get y equals 4 minus 1, 4, comma 2 is the answer. So very straightforward. That's how you get the final answer. So again, solving the system by hand will do the job as follows. Now, if we were to do this by the augmented matrix, so we write 3 minus 4, 2 minus 15, 2, 4, 1, 16, 2, 3, 5, 20. That's the augmented matrix. And you can do this by hand, but you can put it into a calculator. So I'm going to show you how to put that into a calculator again. So you put the matrix 3 by 4, 1, 2, 3 rows, 1, 2, 3, 4 columns. And the reason I'm showing both two of them because it has only 3 columns. I wanted to show you the 4th column. There wasn't enough room. Now, if I go with REF, and again, this is the first portion, this is the second portion, and if I change it to a fraction, answer to fraction, then I can see the entire thing. I hope you see what this means. This means x minus 4/3 y plus 2/3 z equals minus 5, and the rest of it. And the rest of it means the last one, z equals 2, and you have to do back substitution, everybody. However, instead of REF, if I do RREF, I see the last column. Remember the answer we got from the previous page? The last column gives you the answer. So you may use that. So when we are dealing with matrices, you may use a graphing calculator. We want to solve this system. again, you can use a graphing calculator, but it's easy to see if I multiply this one by 8, because this has y and z, this has y and z also. If I multiply this one by 8, I get 16y, 24z, and 8 times negative 14 is negative 112. And this one just repeated. As you can see, everything cancels out on the left side. On the right side, they add up to negative 224. You don't have to do anything. This is a false statement. Therefore, there is no solution. It's an inconsistent system. The solution to this system is an empty set. No solution. We want to solve this system. If I notice, if I multiply this one by 3, I can get rid of the x. So let's multiply by 3. This becomes minus 3x, minus 9y, minus 6. And I hope you see that everything cancels out. So you get 0 equals 0, which is a true statement. Now, what is a true statement? It's a dependent system with infinitely many solutions. So you solve, if you want to write the answer, you write x, and in one of them, for example, in this one, you solve for y, you say 9y is 6 minus 3x, okay? And divide both sides by 9. And now you have x and y, which is negative 1/3 x plus 2/3. This is the way we represented it. If we put that into a calculator, the augmented matrix, -1, -3, -2, 3, 9, 6. And if we do REF or RREF, the bottom is zeros. And a row of zeros means a dependent system. If the row is all zeros except the last one, then there is no solution, inconsistent system.